Number 17 is answered right immediately. Next slide here. What is the hottest layer of the atmosphere? That would be the thermosphere. It's the hot layer above the mesosphere, thermo for warmth. The boundary that separates the two, the colder mesosphere from the warmer thermosphere, is called the mesopause. So that's going to be the other half of number 17. In the thermosphere, oxygen molecules absorb solar rays, warming the air. But because there are relatively few atoms and molecules there, the absorption of a small amount of energy can cause a huge increase in air temperature. And temperatures in the thermosphere vary from day to day, depending on solar activity. If you were in astronomy, you understand how that fluctuates, especially with the solar activity cycle on its 11-year loop there. The low density of the thermosphere also means that an air molecule will move an average distance of over 1 kilometer. That's about over 3,000 feet before it ever collides with another air molecule. So that's more or less like if you were to drive on a highway in the thermosphere, you could see an air molecule, be like, hey, there's an air molecule, and then it would be a whole nother half a mile or more until you saw another air molecule. So good thing we're not trying to breathe that air. A similar air molecule at Earth's surface would move an average distance of less than 1/millionth of a centimeter before it would collide with another, if that gives you an idea of how much more dense the air is here than at the top of the atmosphere. The average distance here is called the mean free path. So that's your question number 18. What is the mean free path of air molecules in the atmosphere? This is probably the answer I would put there, is 3,000 feet. In the thermosphere is where the charged particles from the sun interact with air molecules to produce those auroras. The aurora borealis in the north and the aurora australis in the south. Temperature is kind of a weird concept for the thermosphere because the air density is so incredibly low. If you remember, we had talked about air temperature meaning the hotness or coldness of the air, but the air is so thin, the air molecules are so far apart, that to talk about how hot or cold they are is really kind of meaningless. You could float around in the thermosphere without encountering a single air molecule at all. So you would still feel very, very cold. So temperature, it can't be measured directly. I mean, you don't really like go up with a butterfly net searching for air molecules to measure their kinetic energy. So because the air density is so low, you can't measure temperature directly. What they do instead to measure the temperature of the thermosphere is they can determine the orbital change of satellites caused by the drag of the atmosphere. Even though the air is extremely tenuous, enough air molecules strike a satellite to slow it down, making it drop to a slightly lower orbit. And a number of spacecraft have fallen to Earth for this reason. You can look up which ones recently if you'd like. Typically they can figure out about when that's going to happen and make them fall into the ocean rather than having them endanger any humans here on Earth. That's good. The amount of drag then is related to the density, and it's related to the temperature. And by determining the air density, scientists are able to construct a vertical profile of air temperature. So that's how they're able to figure out the temperature in the upper thermosphere. That's the answer here to number 20, this slide. This is 20. I think I skipped 19. Yep, I did. 19 is right up here. That was the auroras. Sorry about that. There's 19. Okay, at the top of the thermosphere, about 300 miles above the Earth's surface, many of the lighter, faster moving molecules traveling in the right direction can actually escape Earth's gravitational pull. The region where atoms and molecules shoot off into space is sometimes referred to as the exosphere. That's going to be your answer to number 21. Is that very, very top layer. This represents the upper limit of our atmosphere. But it's not really an upper limit as though there were some sort of boundary between our atmosphere and space. There is no boundary. It just sort of gradually blends off into space and eventually there's nothing. So there's no clearly defined edge to the exosphere that separates it from space, and they found particles of Earth's atmosphere as far away as the far side of the moon. Up to this point, we've examined the atmospheric layers. Based on the vertical profile of temperature, but there's another way to do it too. It can also be divided into layers based on its composition. Now, we talked about the vast majority of our atmosphere being nitrogen and oxygen, 99% of it. That's only up to a certain point. The composition of the atmosphere begins to slowly change in the lower part of the thermosphere. Below the mesopause, the composition remains fairly uniform by turbulent mixing, and that lower, well-mixed region is known as the homosphere. So up to about here, they call the homosphere. I'm using green, which is what they use, so that's probably not so great. Let's see if I can change color. How about purple? All right, so there we go. So the homosphere is the troposphere, stratosphere, and mesosphere combined, because it's all well-mixed and has that uniform composition of 78% nitrogen, 21 oxygen. But in the thermosphere, collisions are very infrequent, so the air can't keep itself stirred up. Therefore, diffusion takes over, so heavier atoms and molecules like oxygen and nitrogen will settle down toward the bottom, and the lighter gases will float to the top. It's strictly then based completely on density. That's going to be the heterosphere, hetero meaning different. So different areas of the thermosphere are going to have a different composition depending on how high you are up off the surface of the Earth. So that's going to be your answer here to number 22. Will be on this slide. Kind of a summary. And last one, the ionosphere is another sphere of the atmosphere, another sub-layer of the atmosphere. It's not really a layer. It's kind of an electrified region within the upper atmosphere where large concentrations of ions and free electrons exist. If you've forgotten what ions are from physical science, those are atoms and molecules that have lost or gained one or more electrons, and so they have a charge to them. So if you recall, salt, NaCl, actually when you dissolve it in water, will break apart. That bond is not very strong. It's an ionic bond, so it'll break apart into those two ions, sodium positive and chloride negative. So those would be ions. It's a similar example there. So atoms lose electrons and become positively charged when they can't absorb all of the energy transferred to them by a colliding energetic particle or by the sun's energy. The lower region of the ionosphere is usually about 37 miles above Earth's surface. From here it extends upwards to the top of the atmosphere, so most of it's in the thermosphere. It allows TV and FM radios to pass on through, but at night, particularly at night, it reflects standard AM radio. Come on, English. Reflects standard AM radio waves back to Earth. And so this situation allows AM radio waves to bounce repeatedly off the lower ionosphere and travel great distances. I know there was one night when I was in high school listening to I had heard about this and I thought, well, let's give that a try. And I found an AM radio station in Missouri. I found an AM radio station coming to me from Germany. I thought that was pretty darn awesome. So if you have any questions, be sure to bring those up on Monday in class.